Hey everyone, it's that math magician. On this video, we're going to take a look at inequalities again, but this time we're going to see if we can learn how to solve an inequality. And I'll just let you know right off the bat, solving an equation and solving an inequality, they're essentially the same thing. The only thing we have to make sure is that our final solution makes sense for our answer. So let's go ahead and jump into 3 different examples here of inequalities that we need to solve for x. We want to isolate x. We want x all by itself so we can determine what solutions are going to work. I'm going to go ahead and zoom in now on the one on the left, and we're going to focus in on the one that says 3x minus 4 is greater than 8. Now, you can imagine that if this was not an inequality, it would be an equation with an equal sign there. But that's not what we have. But for this, I think we all know how to solve, or at least I hope you know how to solve a 2-step equation at this point. Well, what's nice is that even though it's an inequality and there is no equal sign, we can still solve it the same way we would an actual equation. All I have to do is move this constant over to the right side and then divide by that coefficient, and we'll have x all by itself. So let's go ahead and do that. I see that I'm subtracting 4 on the left side, so I will have to add 4 on both sides. By adding 4, the 4's on the left-hand side will zero out, leaving us with just 3x greater than 8 plus 4, which is 12. I'm almost done with isolating x. To get x by itself, I think I got to divide by the coefficient. So to get rid of that coefficient, I will need to divide both sides by 3. Those 3's on the left-hand side will cancel to a 1, leaving us with x greater than 12 divided by 3. That makes 4. So that is the solution for this inequality. X is any number that is greater than 4. And now we just want to represent that on a number line so we can show the reader our solution, and they can also see it represented with that number line. So I'm going to go ahead and write 4 in the center, knowing that 5, 6, 7 come off the right-hand side, and 3, 2, 1 are on the left-hand side. Again, 4 is the boundary point here. I see that there is no equal sign for the 4. So I know that 4 cannot be included. So that means instead of doing a solid dot here, since there's no equal sign, that dot is going to have to remain open. Now, x is greater than 4. So it's all the numbers that are bigger than 4, which would mean the right-hand side. So I need to make sure I'm shading in the right-hand side of this number line to show that x is greater than 4. And that's it. That's how you solve an inequality. Still solving it the same way as an equation. Getting x all by itself. We want to isolate our variable and then also represent it on the number line. Let's go ahead and look at another example here. 3 is greater than or equal to 2x minus 5. Again, we want to isolate x. Let's get x all by itself. So I have minus 5 here on the right-hand side. To cancel that out, I'll need to add 5 to both sides so that it zeroes out. 3 plus 5 on the left-hand side is going to make 8. 8 will be greater than or equal to 2x. At this point, just got to divide by the coefficient. So I will go ahead and divide both sides by 2. The 2's on the right-hand side are going to cancel to a 1. And I'm left with 8 divided by 2, which is going to make 4. And 4 is greater than or equal to x. That is our solution. But now notice, it's kind of flipped the opposite way than what we're used to seeing. We're used to seeing x first, the inequality in the middle, and then the number. But for this guy, they're flipped. This says that 4 is greater than or equal to x. And so for some of you out there, this might be a bit confusing. But the good news is that we can actually swap that inequality and write it the way that we're used to writing it. What I mean is the x and the 4, we'll just swap their places. I'll write the x first. I'll write the 4 last. But since I'm flipping those, right, I'm taking the x and the 4 and I'm moving them, I also got to flip that inequality in the middle. So what once was greater than or equal to will now become less than or equal to. These two boxed expressions actually represent the same thing. They're just written in a different order. X is less than or equal to 4, or 4 is greater than or equal to X. I think it's easier to read it this way because once I see it that way, I know that I can create my number line, very similar to the one we just did over there. I know that there's an equal sign. An equal sign means that I need to include the solid dot because I'm including 4. And I now know that X is less than or equal to 4, which means that I'm going to be shading in all the numbers here that are less than 4. Okay. Now, for some of you, you might not have to change it because looking here, I could result with this number line the same way. Think about this. 4 is greater than or equal to X. That means that 4 is the biggest number that X can be. And looking at our number line here, we see that 4 is the biggest number that X can be. So for some of you, you might be able to create your number line from an expression written backwards. Some of you might need to flip it the right way. Whatever works for you is fine, just as long as you're able to get that solution and understand what that solution means. All right, we got one more example I want to get through, and that is the example right here. Negative 4x plus 2 is less than negative 6. Again, let's move that coefficient from the left-hand side to the right-hand side. So I'm going to go ahead and subtract 2. Doing that will cancel out the 2's on the left-hand side. They zero out. And I'm left with negative 4x is less than negative 6 minus 2. That makes negative 8. At this point, I know to divide by that coefficient of negative 4. By dividing by negative 4, those cancel out to a 1. And I'm left with on the left-hand side x. On the right-hand side, negative 8 divided by negative 4 will result in a 2. But notice that I'm leaving the inequality blank for the time being. Here is a final rule that you need to know when solving an inequality. At any point, if you divide or multiply by a negative number, you have to flip the inequality. What once was a less than symbol will now turn into a greater than symbol because of the fact that we are dividing by that negative number. And for some of you out there scratching your head, probably wondering, why in the world would we have to do that? Let me explain to you and show you why we have to flip that inequality. Had I written this the old way and forgot to flip it and left it as less than 2, think about that solution. X can be less than 2. X can be a number smaller than 2. Well, you know what number is smaller than 2? I think 0 is smaller than 2. So then why don't I just take 0 and plug that into our original inequality? Because we're saying that the solution for this are any numbers that are less than 2. And since 0 is less than 2, I should plug that in and get a true statement at the end. And watch what happens. Negative 4 times 0, that makes 0. And I have 0 plus 2, and 0 plus 2 makes 2. And look at this final statement that's left for us. 2 is less than negative 6. That right there is not a true statement. 2 is not less than negative 6, which means then that 0 is not a solution to this inequality. We're not talking about numbers less than 2, because less than 2, they don't work. We see here that when I plugged in a number less than 2, our statement at the end was false. This is why whenever you are dividing or multiplying by a negative number for an inequality, you gotta flip that inequality because x is greater than 2. And to show you why, let's pick a number that we can plug in for x that is greater than 2. And it should end up working for us. So let's see, x is greater than 2. I think 3 is greater than 2. So plugging in 3 should work. Negative 4 times 3, well, that makes negative 12. And let's see, negative 12 plus 2, that makes negative 10. And looking at that final statement, is negative 10 less than negative 6? You betcha. Negative 10 is less than negative 6, which means that the 3 over here does work, which means that x then is greater than 2. It is not less than 2 because less than 2 did not work for us. It's all the numbers greater than 2. So please, as you work through future classworks, homeworks, quizzes, tests, whenever you're solving an inequality, if you divide or multiply both sides by a negative number, be sure to flip the inequality. Our final step here is now to write this as a number line. We know that 2 is the boundary point. There is no equal sign here in the inequality. It is greater than 2, so we know that we're going to have an open circle. All the numbers greater than 2, that's going to be all the numbers shaded to the right. Knowing that 3 did work. 3 over here worked because we got a check mark. 0 did not work. It gave us that false statement. So that's how you do it. That's how you solve an inequality. Again, very similar to solving an equation, but sometimes you might have to check your answer to verify that it is a true solution. It's that Math Magician, and I'll see you on the next video.